Hey guys, Spiral Review for Spiral 8. This might be a little bit out of order and some other stuff going on in terms of moving things from different Spiral Reviews from previous years, so I apologize for that. I'd like to do the general angles and radians part. First off, we got to sketch an angle to find two coterminal angles, and we're going to start with negative 350. So in terms of where that would be, negative 350 would be just about 360. Two coterminal angles, one would be at 10 degrees, and another might be at, if I went around another full time, plus 10, 370 degrees. Those are not the only coterminals, but those would be two coterminals. Part B, 660 degrees. Okay, well there is positive, that's 360, 450, 540, 630, and then a little bit more to get to 660. Two coterminal angles, well 720 would complete that. So we are looking at 60 degrees in the negative. And then if I added 360 to that, we'd also end up at 300 degrees in the positive. I'm going to go down, converting from degrees to radians, negative 150 times pi over 180 is going to end up being negative 150 over 180 pi, and I'm going to reduce this. Those zeros cancel out. 15 over 18, if I divide both of those by 3, I get negative 5 pi over 6. Next up, we have an angle drawn for us. We've got something in blue, that's this guy. And we're trying to figure out what this angle is, and they tell us that this angle measures 170 degrees. Well, this angle would end up being negative 170 because we're going the other way. That's crazy. And the reference angle, whatever it would take to get to 180, that's going to be 10 degrees is the reference angle. Reference angles are always positive and always going to be less than 90 degrees. Finally, we would do 11 pi over 6, converting to degrees. That's times 180 over pi. My pi's cancel out. 180 over 6 is going to be 30. 11 times 30 is going to be 330 degrees. And that's it. Hey guys, this is Spiral Review for Spiral 15. First start off with some unit circle trig stuff, and to do that I'm going to look at cosecant of negative 5 pi over 4. First thing I've got to do is realize that cosecant is going to be the reciprocal of sine of negative 5 pi over 4. So if I find sine of negative 5 pi over 4, I'm going to flip it to get cosecant. Second thing is I need to figure out where negative 5 pi over 4 is. Okay, I know negative goes backwards, so that's negative 2 pi over 4, negative 4 pi over 4, negative 5. Negative 5 pi over 4 is in quadrant 2, where sine is positive. And if sine is positive, cosecant is positive. Okay, last piece is that I need to realize that this is a 45, 45, 90 right triangle. And in setting this up, we're looking at 1 root 2 over 2 and root 2 over 2. Sine would be the y value, or root 2 over 2. So cosecant would be 2 over the square root of 2. And if you want to simplify this, you can multiply the top and bottom by square root of 2. And you get 2 root 2 over 2, or the square root of 2. Number 2 is secant of 8 pi over 3. Similarly, I need to know that this is the reciprocal of cosine. So if I find cosine, I can just flip it. I need to know where 8 pi over 3 is. Okay, there's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3 takes me back to 0, 7 pi over 3, 8 pi over 3 is this answer. This is quadrant 2. where cosine is negative. And since cosine is negative, secant is negative. I know that pi over 3 angles are going to be a 60-degree right triangle as the base. And we're looking at a triangle that looks like this. Cosine is 1/2. Therefore, secant is 2/1. Number 3, cosine of 19 pi over 6. I'm going to use a slightly different approach to this one just to kind of talk about some varied ways to find things. And I'd like to get this back down to less than 2 pi. So if we're dealing with pi's over 6, I know that 12 pi over 6 is the same as 2 pi. Then a coterminal angle for this would be 19 pi over 6 minus 12 pi over 6, which is 7 pi over 6. And that's going to be down here, where cosine is negative. I know this is going to be a 30 reference angle because of the pi over 6 part. So we've got a half, root 3 over 2, and 1. And cosine is going to be our adjacent side divided by 1. In this quadrant, it's negative, so we got negative root 3 over 2. We're looking at secant of negative 7 pi over 4. Again, this is going to be the reciprocal of cosine. I'm going to look at another possible approach to this. So if I start negative 7 pi over 4, I know I can add or subtract 2 pi to this to bring it into another coterminal angle. 2 pi is the same as 8 pi over 4, which is positive 1 pi over 4. Hey, that's nice. 1 pi over 4 is in the first quadrant. Cosine is positive in the first quadrant. Cosine of pi over 4 is going to be root 2 over 2 because we're dealing with a 45-degree angle. So if cosine is root 2 over 2, secant is 2 over root 2, or the square root of 2. Cotangent of negative 13 pi over 6. Similarly, I'm going to try to make this into a nice and easy angle for me to see where it is. And in looking at that, I'm going to say, okay, negative 13 pi over 6 plus 2 pi, or plus 12 pi over 6 is equal to negative pi over 6. Okay, that's not too bad. That's just down pi over 6 in quadrant 4. Cotangent is going to be the reciprocal of tangent. And with pi over 6, we're looking at a 30-degree reference angle. So you've got a half and a root 3 over 2. Since tangent would be 1/2 divided by root 3 over 2, cotangent is going to be the reciprocal. So we're looking at root 3 over 2 divided by 1/2, which in quadrant 4 is going to be negative. We're looking for the negative version of this. So negative root 3 is going to be our answer. And finally, number 6, sine of 2 pi. Well, 2 pi is going to come back to here, back to 0. I've got the coordinate 1, 0. Sine is the y value. So sine of 2 pi is 0. Next up, we're graphing sine and cosine. I've got to identify 5 points along this. And I might start by identifying the midline. So my midline is going to be at -1. That means I'm going to go up and down from that point. A couple hints. First of all, this is just in the vertical transformation section. Second of all, there's nothing going on inside my sine function. Therefore, there's no slide here. So all I have to do is care about the fact that sine should go from 0 to 2 pi. I don't know, let's go 1, 2, 3, 4. I'll make that pi 1, 2, 3, 4, make that 2 pi. And we know that sine starts normally on the midline with an angle of 0. It hits the midline again at pi and at 2 pi. Now we're going to take the amplitude into consideration. Halfway between my first 2 points, we're going to be the amplitude. In this case, we're going down because it's negative. So amplitude below that value. Halfway between pi and 2 pi, I'm going to be 2 above that value. My function looks like this. All right, here I'm asked to find an example of an equation using sine, an example of an equation using cosine. Since we're starting at the top and cosine starts at the top, I'm going to do that first. Okay, first thing we're going to say the amplitude is going to be, I'm going from -4 up to 1. It's going to be 5. My period, going from 0 to 2 pi peak to peak, is 2 pi, so I know that bx is equal to 2 pi, and in this case, x, the period, is 2 pi, so b equals 1. Okay. Phase shift. For cosine, we're starting at 0, that's the top. None for cosine. And for sine, I know I need to start at the middle. It looks like I can start at a phase shift of pi over 2 to the right. Last bit of information I need is the midline. And here it's pretty clearly at -4. Okay, so cosine. We know we have an amplitude of 5, a b value of 1, no phase shift, so 0, and a midline of -4. For sine, since we're going down, it's going to be -5 sine. Period is still 2 pi, so b is 1. X and pi over 2 to the right is minus pi over 2. And we're looking at a midline of -4. Next up, we have to graph things that have some other things going on. This one has some horizontal shift and some issues with period. So, first thing I might do is to factor out a 3 to make this a little bit easier to deal with. That makes 3 theta plus pi over 3. Okay, I've got a midline of +2. So glad I'm way up there. An amplitude of 1. Okay, I guess that makes not too bad. My period, so 3x is equal to 2 pi. That means that x equals 2 pi over 3. Okay, maybe make this 1, 2, 3, 4. Pi over 3, 1, 2, 3, 4. 2 pi over 3, just kind of arbitrarily for the sake of nice and easy. Sine needs to be on the midline at all 3 of these values. Okay, we've got an amplitude of 1, which means we've got to go up 1, halfway between those two, and down 1, halfway between those two. I get a curve that looks something like this. For number 9, I've got to make a sine and a cosine graph using this, sine cosine equation using this graph. I notice that midline is equal to 1, that my period goes from 0 to 2 pi, that means that b times 2 pi is equal to 2 pi, which means that b is equal to 1. I've got to get an amplitude, and amplitude I'm going from 1 to 3. So it's an amplitude of 2. And then I got to talk about phase shift. Cosine, I start at the top or the bottom. Here I start at the bottom, and it's at 0, so there's no phase shift. And for sine, I need to start at the midline. My first midline point is at pi over 6. And I can say that we're pi over 6 to the right. Okay, cosine equation first. I'm going to build my equation. We know the midline's plus 1. Cosine is starting at the negative side, so it's going to be negative amplitude, negative 2. B is going to be 1, and we're looking at x minus 0 because we said no phase shift. For sine, the period doesn't change. The midline doesn't change. And we're going up instead of down, so we get a positive 2 as our thing. And by thing, I mean amplitude. And we're pi over 6 to the right, so that's minus pi over 6. That's one equation for cosine, one equation for sine. Both that give us this graph.
My cousin has value.
Here we're looking at trig models. I've got to start by finding my different parameters to write a sine or cosine equation for this. First up, I might find the midline. And to do that, I'm going to take the highest and lowest values. My highest value appears to be 16. My lowest value appears to be 6. If I divide that by 2, I get 11. Okay. My next thing I'll look for is my amplitude. And instead of adding these, I'm going to subtract them. So 16 minus 6 is 10 divided by 2. A is equal to 5. Okay. My period, I'm going to go for max to max. So from the 16 value to the 16 value. And it looks like my period here is going to go from 1 to 7, which is 6. All right. So if 2 pi over b is equal to 6, that means that b is going to be 2 pi over 6. And finally, I've got to take a look at this and decide whether I want to use sine or cosine. I'm a little partial to using cosine, especially if I know where one of my max values is. And here, I've got a pretty clear max, and that occurs at a phase shift of 1. I know that cosine is a positive graph when it goes from max to max. So we'd be looking at our graph going from this as a rough sketch of one period of the graph. Okay. In creating cosine equation, I'm going to take my amplitude, which is 5. We said this is a positive cosine, so 5 cosine. My b value is 2 pi over 6. Got x minus my c value, and then plus my d value, which we said was 11. This is the model for this situation.